Hello and welcome to our first session after the Big Inclusive Futures Festival. Most of us are quite exhausted today after a huge amount of work went into the whole event. This is the first of a series of sessions looking back at what has been produced during the whole festival. There are, of course, also a whole series of videos that have been uploaded online onto our YouTube site. But this is a session where we'll be showing a video and also speaking to some of the workshop leaders. We'll have maybe about 7 or 8 of these sessions before we lock back into our usual kind of routine of thematized sessions every Saturday. So I'd like to start by inviting Chao to show us a video of some of the exhibition that has been going on in Shanghai. As you all know, we had a series of different types of workshops, some completely online, and a few hybrid ones where the fabrication took place mainly in Shanghai, but also in one case in Cairo in Egypt. So I'd like to welcome Chao, who will show us a video of the exhibition in Shanghai.
Okay, thank you, Neil. So as Neil has mentioned, we opened our physical exhibition at the Gallery of College of Architecture and Urban Planning at Tongji University. So let me show you a video. So this is a kind of short video showing a kind of overview of the physical exhibition at Tongji University. So the exhibition is from today, July 10th, and to September 30th. So it's kind of a very long exhibition. For those of you who can get into the campus, you may go to our gallery to check the outcomes of over 100 workshops, and also some kind of digital fabrication projects by Tongji, ICD, ETH, and some other schools. Meanwhile, we have been working with a group of very interesting people, trying to work out a way of building a virtual model of the exact gallery space. So for those of you from all around the world, you can later check in our website to see the virtual exhibition. So that's the plan, and we will keep updating the information on the website. You can just go check there and follow us. Okay, thank you, Neil.
Yeah, maybe I can just say a few words. For those of you unfamiliar, what Chao was showing was the exhibition space in the College of Architecture and Urban Planning at Tongji University in Shanghai. This, of course, was where the first ever event was hosted back in 2011, when I brought a group of students from under the aegis of the American Academy in China across to Shanghai to collaborate with some students from Tongji, and I think there were also some students from South China University of Technology, also there. That event, which started off very small, grew across over the years until 2019. We had some like 800 applicants for that. And then we went online. Of course, the rest is history. It became a major global event. But this was something that on which everything was based. The very starting point, we had a kind of formula which we kept going, which is to say an exhibition, a conference, and a series of workshops. So even though the scale itself has grown. And that exhibition is housed in the basement, as it were, of the College of Architecture and Urban Planning, Tongji University. And each year it features, well, it has the last, I think, about 4 or 5 years, has featured a bridge that has been the product of a workshop. In some cases, I think in one case it was the second ever 3D printed bridge, and it's in a sense the bridge has become a kind of, I guess, a kind of almost like a characteristic of the exhibition, a bit like the ICD pavilions, exploring the possibility of how we can use these computational tools to introduce ever more structurally efficient ways of operating. I don't know if you'd like to say something, Chao, about that bridge itself. As I understand it, it's yet to be, the concrete is yet to be cured. There are some props that are holding up the structure for the moment, and it's going to take 30 days for the concrete to be cured, and the struts will be removed. And I understand that the top section is 3D printed, a form of plastic. And do you want to say something about that, Chao? Just about the structure of it, how it was made? Maybe show the video again, just to go and to see it, because I think that bridge is certainly worth.
I think from what I know is that, yes, the top part is 3D printing, and then the bottom part, the supporting structure is made by concrete and with a kind of knitting mold. But I think it's better for Wang Xiang and ETH group to give you more details about the bridge. But I can only say some kind of general information about it. Yeah.
So today we're going to have a few presentations by some of the workshop instructors. And I'd like to invite Emmanuel Ko to, first of all, show his work. Emmanuel, for those of you who don't know him, he's become quite famous. I think he was the first person to publish a book on AI and architecture. I know that this week Wan Yu has also published a book on AI and architecture. Emmanuel came across to the AA. I don't know how long ago it was now, but when Elisa Andrzejczyk was certainly teaching there some time ago, studied on the ADRL, and then went to work a number of places, and then was one of the first architects ever, I think, to undertake a PhD on AI and architecture in EPFL, I think it is in Lausanne in Switzerland, and has now become an assistant professor at Singapore University of Technology and Design. Have I got that right? Or is it Design Technology?
Technology and Design.
Sorry?
Thanks. Technology and Design.
Technology and Design. Welcome, Emmanuel.
Although design should come first, maybe. Right, thanks. Right, so let me share my screen now. Give me a second. Right. Right. Thanks, Neil, for the introduction. So, I'm assistant professor at SUTD, and I direct the research lab called Artificial Architecture at SUTD. I'm also teaching in 2 different programs. One is the Architecture and Sustainable Design, and the other one is the new program called the Design and Artificial Intelligence program. So, so first of all, thanks to the Digital Future team, Philip, especially Philip Yan and Nilich for organizing this amazing international event, bringing so many people together, both from within as well as beyond the discipline of architecture. So I'm happy to have this opportunity to conduct a workshop on the theme of AI in architecture. First, well, again, actually, because I did it last year, 2020, it was titled Discrete Sampling. And this time around, it was titled AI Sampling. There are actually many related themes that I've been exploring. a second. Right. So here's a screenshot of the previous year discrete sampling in 2020. And back then, it was a relatively short duration for a workshop, 20 hours in total, and about 20 plus students. From many places, I was pretty surprised that there are kind of diverse profiles of participants, from teachers to practicing architects and PhDs and master students as well. And for this year, mine was one of the, well, actually there are more AI workshops for this year, in fact. So mine is the one of the 23 workshops on AI being offered. Similarly, with a focus on an end-to-end 3D form learning and generation with deep neural networks. The pro image and the title of the workshop were actually taken from my recent work called AI Sampling Singapore, currently on display at the 17th Venice Architecture Biennale, Italian virtual pavilion, titled CDX Venice, curated by Tom Kovat and Alessandro Melis. More specifically, it is part of the AI and Architecture Pavilion curated by Matthias Da Campo, also featuring the works from the rest of our neuro architecture group members, namely Sandra Menninger, as well as Daniel Abulaya. So in that project, Singapore being the site of data extraction as well as design generation. So the data sets were in fact real buildings extracted as digital 3D models. In this case, we are not talking about, I mean, you've probably seen the image for the promo is the chair, but actually in this particular project, looking at every public housing building in Singapore in the form of semantically enriched 3D models. So on the left, you see the 3D GAN in walking latent space, and on the right, the architecturized version in the latent walk. Actually, this model took a few weeks to train to eventually get something out of it. There is a key difference between the 2020 and the 2021 workshop, though, and it is the underlying sampling architecture implemented for both workshops. So in the 2020, it was the sampling in continuous space. So essentially, again, architecture. It is continuous, implicit, latent, and fast. This is kind of on the left is a typical vanilla, again, simplified illustration. And in 2021, it is about sampling in discrete sequence, which I think later on it will become much clearer for those who are less familiar with the non-GAN architecture implemented. Previously, for the last year, it was implemented in PyTorch. This year, I introduced the student TensorFlow, implementing in TensorFlow. And in this case, a simplified illustration of an autoregressive model with, in this case, pixel CNN. So therefore, although still an extension of my ongoing work in 3D GAN, for this year, the workshop focuses on transformer-based deep learning models. More specifically, a combination of self-attention, encoder-decoder, autoregressive, and more crucially, it is about sequentially learning with discrete embeddings, discrete representation, and sequentially generating using discrete sampling. You see it in a bit from the output of the workshop. So the workshop started off with a more in-depth understanding of something I've been talking about for some time, the theory of architecture sampling. And then during the workshop, students were then introduced with what I think rather speedy tutorials on TensorFlow and Grasshopper. Grasshopper mainly for the more complex 3 geometric articulation. And the remaining days spent on team-based design projects, including troubleshooting of the training and inference processes. So I actually should apologize to there were more than 100 applicants who had been unfortunately placed on the waiting list due to the limited seats available for the workshop. It was kind of designed for a smaller group, so I wasn't kind of ready to get so many people on the workshop. But in fact, I do not actually know any of those in a waiting list, so I actually need to apologize, since it was a kind of a blind review process, quite unlike last year, with minimal description or even and the portfolio samples as so there isn't really a way to know who you are or which school. So yeah, maybe next time we may have an opportunity to work together. Therefore, I would thank not only those who eventually made it to the workshop. There were about 15 students, and those who were previously in the waiting list, but very interested in kind of work that I'm doing. Some of my students at the workshop, snapshot on the Zoom on the last day, I think mostly happy looking faces, I hope. Here's the highly compressed version of the workshop outcome formatted according to the, I think the exhibition format. The Digital Future team asked for, I think, 4 pages or something. So briefly, the idea is that learning 3D meshes directly and then generating them in a sequential way. So on the right, I'll show a bit more details later on. So on the left, you see some training and some outputs meshes in 3D, and on the right, this sequential sampling process. These examples is kind of combining different types of 3D models, specifically in this case the tree structures and some furniture, but mainly getting students to kind of play around with it. And over here you see the training process as the models slowly figuring out what's going on. In the beginning, mainly furniture, and eventually it figure out how to kind of combine the more node-based, branching-based structure and the surface volumetric structure. So I've compiled 2 minutes video that hopefully summarizes the design output of the workshop and gives more insight to the breadth of work produced during these 5 days, although it was really just 10 hours, excluding the training time for the deep learning models during outside the 10 hours. Let me just run this. There isn't any audio, so yeah. So you see that it's actually sampling every vertex and then figuring out the edges and eventually creating meshes from it. In this case, it's actually generating from this training set of furniture as a kind of a toy example. And then you see the training is trying to figure out how to kind of join the points, almost like a dot-to-dot game that one plays as a child. And on the left is the, well, I have a more slowed down explanation and so on. So other examples, so this is a combination. So on the left, you see this sampling of the vertices. And then the faces, the model is trying to figure out which are the points to create a face. So you see the sequence here with the connections, if it's obvious enough. Some students look at more vernacular architecture. So here again, the training process of Greek temples. Some students, they were actually quite interested in this. Other ones, also the training with different ratio. In this particular project, for instance, look at the courtyard. So if you learn from a single courtyard, if you learn a combination of courtyard and vertical cube structures, or you learn a courtyard with topography. So this is actually the actual sequence process. So given that the video was actually quite compressed in content, I will spend just a few minutes to talk about the other, or some of the projects in slightly slow down process. Yeah. So this in this, for example, here is the traditional Iranian architecture. One group actually looked at the wind tower found in what typically found in regions like along the Persian Gulf. So the idea is to figure out whether it's possible to learn the structure of these architecture which essentially are used typically to passively channel wind stream from the top of the tower to the bottom, where the internal rooms could be found. So you see contemporary and traditional vernacular towers called the wind catcher. So here we see some examples where sometimes the model overfit. It literally just memorize the inputs, which is a bad thing. It has to do with the batch size and also the time train, and of course the size of the training set. But at a certain moment, for this group at least, they got something interesting in between. So here we see a similar process of the vertex model and the face model, trying to figure out. So the face model is generating conditioned by the vertices, the distribution of the vertices. Now they're kind of testing. I think the video is almost finished. Yeah, just move quickly. So examples here, they were also doing some wind analysis using the CFD, computational fluid dynamics, to figure out whether the traditional one from the training set and the one that's been generated could in fact perform quite differently. This other project explore whether via a kind of common architecture object, which is you probably saw just now from the video, this self-supporting tree structure which was generated using an equilibrium method. The tree structure is then synthesized with 3 other objects. Since the workshop is actually faster to play with some of these toy data sets, the sofa, the spiral, and the tables. The project is about really questioning whether these objects used for the training might somehow inherit the structural attributes of the input tree structure. So some renderings of the geometric articulation from the outputs. Also trying to somehow include the texture of the different types of training set. Meaning in this case, this sofa texture and the joints and edges of the tree structure. One student also try to figure out if she could somehow generate some tree-like structure tables. Anyway, so another project looked at the Greek temples as you saw just now in the video, trying to figure out if given the training set on the left, they somehow generate a few I think interesting in between models on the right. As you can see, they kind of a quick video to show the process, because the vertex distribution has been discretized and quantized. Therefore, the symmetry of the generated models 3D design could be somehow often guaranteed. So you see this really kind of nice symmetry. Of course, we could choose not to have that symmetry, but in this case for the workshop, the symmetry has been included, meaning that the quantization naturally gives rise to the symmetry. This project, which in the beginning of the video, which I showed, so the training set on the right and the outputs, and some of the outputs on the right, we see instances where the chair becomes a table and becomes a sofa, which is the idea to kind of explore the synthesis of ergonomics and structure of these objects as a start. Yeah, so on the left, we see the inputs, and on the right, some of the interesting outputs. Zoom in of the left, inputs, on the right, the outputs. This project we saw on the video is about the traditional Iranian. I've got a few Iranian students in the workshop. So one of the groups was really interested in the traditional courtyard. So here we see that on the left is the training process. On the right, some outputs which a bit messed up, but it somehow learned a bit of in this case, for instance, the combination of vertical structure with the Courtyard typology. Here, maybe it's slightly more successful, where the student tried to combine the predominantly flat Courtyard typology with topography. So in this case, we see instances where the Courtyard generated Courtyard design actually exhibit that kind of topographical distribution at the same time retaining the Courtyard, like here, for instance. Yeah. And the last group, in this case, they got two different data sets. One, which is on the top right, more orthogonally composed meshing with regulated internal connections. And type B, which is kind of the opposite, just to figure out if the model could eventually synthesize them and mixing up the vertex distribution. So again, by changing the ratio of the two types of data set and looking at the results. So these are some of the results. Of course, training also changing the number of epochs to train. Some examples. Yeah, so this is pretty much the outputs for the workshop. Thanks.
Imran, maybe we can have a little, just a brief chat about that before we move on, because I think it's to my mind, it's fascinating how things have been developing. A few years ago, actually 2013, Philip Yan and I published a book on the number of workshops in general that are happening in China. In those days, the AA was sending a team over to have each year in Shanghai and Shenzhen and other places to have workshops and those things. There was a culture emerging anyway. And now there's this culture of AI workshops emerging, which is kind of astonishing in its own right. I mean, in some ways, you don't look back on these things because you're so kind of forward looking. At the same time, it is, just to do a study, I mean, or even just a statistical study about how many of these workshops have been happening. I think we started off with one with Wang Yu about 4 years ago. Then we had about four. Then it's gradually increasing. Do you want to comment maybe on that? Because I mean, one thing that you are obviously at the forefront of many of these things. You're one of the first students of architecture, shall we say, to have done a PhD on AI, and you're the first to publish a book on the thing. How do you see this global phenomenon emerging? And what is good about it? What is bad about it? Maybe.
Well, I think it has to do with the exposure. When I was kind of testing out style transfer back then, in 2016 in Shanghai as well, right, with the AA Shanghai Visiting School. Back then, nobody was talking about it. Students were kind of rubbing their head, figuring out what on earth was I doing. And we spent actually half of the time just installing stuff, which was really ridiculous. And then eventually, but the AA Visiting School was kind of a good context. So I was given the chance to somehow build up that exploration from 2016 onwards. And eventually, it was also the same year in 2016 that I decided to do a PhD and looking at this AI topic more seriously. And I think, for instance, in the case of Digital Future, because the very fact that suddenly every architecture student seems to be exposed to this new thing, a new toy, and it also became much more accessible, right? In the past, we were doing piano and there wasn't even Google Colab, and it was a pain. We can't run on anything. I mean, if you don't have a GPU, fine. In fact, we were running on CPU in 2016, which was so painful. But now it's so accessible that suddenly it's possible for students to kind of quite quickly play with it, and for maybe teachers in architecture to play with it in a more serious way, a more kind of sustained way, to eventually give workshops and exchange ideas with other teachers in other universities. So the good thing is that everyone now kind of have this opportunity to do it. The problem that I'm seeing in recent years, which is actually very recent, is that there is this homogeneity increasingly, because suddenly if someone started to do this, everyone start doing it. And I think it's also quite unhealthy, because there's no space to kind of step back and say, I don't want to do GAN, for instance, which is one of the motivations to doing this transformer-based architecture, this auto-regressive model for this workshop, is to see if there are other channels beyond what is most accessible at this point, at least. Yeah, I mean, nowadays it's almost trivial to train a style gun on runway ML, for instance. Yeah. Don't know if I answer your question.
Well, I just to kind of reflect on things. I mean, it is astonishing the speed at which it's become a kind of vogue in some ways, and maybe it's problematic becoming a vogue. But I recall. I mean, I myself was back in 2018. I remember putting in an application for the British Pavilion for the Venice Biennale. And I was teaming up with Zaha Hadid Architects and with Google. I mean, Google, of course, they have the famous Artist Machine Intelligence Group, so they're probably world leaders. And we didn't even get shortlisted, which is kind of a sign of the times. And now, of course, things are developing, and there's an AD that you're part of course, that is coming out next year, beginning next year, on AI and Architecture, the first one that's come out. And as I mentioned, your book's come out, and Wan Yuhe's book has come out literally this week, and mine is going to be coming out in November. But I guess, I mean, it's interesting how these things pick up in some ways, and maybe problematic, because I think there are still huge problems with it, and people are kind of maybe seeing it as the latest trendiest thing, and they'll explore it, maybe even abandon it. I don't know, but it seems to be with the very beginning of these things. And I like the comment that Benjamin Bratton makes about computation in general. He says we are only at the silent movies period of computation, and I think that in terms of AI, we're even more primitive in some ways. But let's see where it will lead. Anyway, thank you, Emmanuel. It's really, thank you for running the workshop, and it's great to be able to share your ideas around the world, and it's great to see also so many students in Iran, a country where they can not really afford to go and study abroad, be able to have access to these things. I'd also I now would like to move on to Hans Jakob Wagner, who is from ICT Stuttgart, who has been collaborating with Tongji in one of the hybrid workshops, which was looking at the possibility of working remotely and building online. So Hans Jakob is a research associate there. He has been since 2013 under Akim Menges, and for those of you who don't know, Akim Menges runs this institute there that is in the same university as Frei Otto, but is unlike Frei Otto, it's very computational and has had a major impact on the world as a whole. There was also another workshop that was run by Dylan Woods and Tiffany Cheng also during the event, and I think Yassi Tahuni, that's right. So I'd like to invite Hans Jakob to say something about the collaboration that they were doing at a workshop this year. Hans Jakob.
Thanks, Neil. Yeah, so we had the incredible pleasure to collaborate again to continue the ICD and Tongji collaboration at the Digital Futures that was running, I think now since 5 years, 7 years, maybe even, with Achim and Professor Philipp Yuan. And yeah, maybe I just share my screen and show the online participants' work and the topic of the workshop, and then I think Jaihua will show the result that was prepared at the Tongji campus, the demonstrator that was built in parallel. If that's what we should do, I think that would be my plan now. All right, then I try to share my screen. Just a second. Is that visible?
Not yet. It says it has started screen sharing. Okay, yeah.
Is it now?
Yes.
Great. Great. All right, so our workshop was called Spatial Glulam Structures, with the main goal being to design, to explore the design potentials of in-situ robotic timber construction. And this really is a continuation of the workshop that we were running kind of with the same team last year, where before Corona, we actually had the idea of preparing kind of this new robotic setup that was mostly developed by our colleagues at Tongji, where we had the pleasure to give a bit of expertise on the gluing, but that's basically it. And the idea was to explore how we can actually use a mobile platform, a mobile robotic platform, to assemble timber structures on site directly. And this year we continued this collaboration further, and this is what we're going to talk about now. Yeah, we had a great group of participants. I guess similar to Emmanuel Co before, we also had like around 100 applications, and it was really hard to to choose because it was just like amazing, really amazing applications. And yeah, in the end, we worked with quite a selective group because we of course always try to also keep the teaching quality high. I guess there is no point in not being able to really teach on a one-on-one level. We had the workshop run for 7 days, 5 hours each day. And there was one group working online with us. And then there was an on-site fabrication group in Tongji. And yeah, the topic of the workshop is spatial glulam structures. I guess that's kind of a descriptive title. So we're basically speculating on what happens if you laminate glulam on site, right? And of course, the big thing that you can do if you try to afford that is that you can laminate it in whatever geometry you want, right? Instead of just laminating beams, you can laminate three-dimensional spatial structures. And given the robotic mobile platform, we speculate that this might become possible in the near future, right? This is kind of going along the lines of what we were discussing also in ICD, where we're kind of very interested in prefabrication, but the limitation of prefabrication is of course always the transportation of the building modules. And what we are kind of proposing is that instead of having transportable building modules, right, that you ship around the globe, you could propose a kind of platform-based robotic timber construction approach where the robotic and the machinery is actually transportable, flexible, and that these kind of machines come to the site. And even if it's prefabrication, if you set up like a small mini factory on site, then you can break free from a lot of the constraints that are currently limiting the offsite construction. And yeah, with this workshop, we have like an amazing robotic platform available from Tongji that you can see here on the right side, which is basically an industrial robot arm equipped for timber assembly. So it has a gripper, it has a gluing station, it has a nail gun, and it can assemble autonomously on site using these tools. Of course, we're gluing. This is maybe a bit of like a high-tech approach. There's a lot of discussion around also disassemblable structures. In our case, we really kind of hinge on the point that the gluing at the end is just the most performative way of joining timber, where the joints are always the weakest part with a typical screw connection having like 5%, 10% of the stiffness of the actual part, right? So if you're talking about performative structures, there is almost no way around gluing, and this is really what we're trying to do here. And of course, if you laminate the structures on site, you can also kind of radically rethink the joining tectonics of what a timber structure looks like, because of course you can kind of interweave your laminated beams on site, right? And yeah, with this participants, we really try to tackle this kind of question of what we can do with such an approach from a really diverse kind of point of view. We gave the participants a huge amount of freedom, which of course also demanded a lot of kind of ownership from them to really push ideas that they have. And prepare those and bring it to a presentable state within only a week. And the three teams that the three topics that we tried to push are, first of all, just design explorations, right? So what kind of structures might be possible? Then the tectonic grammar. So how do the members really come together? How are they joined, and what is the logic of that joining procedures? And last but not least, of course, like the robotic strategies of how we can really simulate and program the robotics, which of course was then in the online teaching mostly like revolving around simulations, but at the same time we were having the on-site team running the robot in Tongji. Yeah, the idea now would be to just go through a couple of those outputs. We had the first group with Dan Liang, Wei Ye, and Han Lindong, really exploring what the surface-based Glulam structure would look like, right? So instead of laminating a beam, they proposed to laminate a surface that, of course, can take almost any geometry. And yeah, they did an amazing job looking also at the robotic simulations of how these actually come together, and definitely one of the projects where I think it is developed to a point where if we would want to build a demonstrator immediately, right, we could basically run with that proposal and it would be pretty much ready to go. And really nice design explorations also from that team. So it's really great to see kind of a comprehensive project. Then other teams, Group 5 with Jianhua Huang, Jiaming Li, and Abhishek Shinde, they approach the topic from a, let's say, more bottom-up point of view, where they really try to understand like what would be the computational approach towards such structures, right? And what would be the logic of actually aggregating those sticks, and how could you train a computer, or how could you train a robot in that case, to really build meaningful structures? Their hypothesis is that the criteria to define what is a good position for a stick, or what is a good assembly of sticks, is the overlap of the sticks. So kind of like the lamination surface, right? Which kind of comes from I guess from a more structurally driven point of view, but of course is also simple enough to really build like more extensive models based on that. And they thought a lot about how the robotic fabrication can be embedded in that with simulations, and how you can really compute kind of like an optimum state of aggregation. Yeah, and also in this group, it's kind of amazing to see what can be done within 1 week of course being like an intense workshop, right, with kind of constant feedback and constant back and forth, but really amazing what this group was able to do, with already starting the first optimization circles and already kind of testing the hypothesis of what it really means of taking this kind of overlap surface as the main input. And well, they also tried to speculate on what kind of structures would come out of this kind of algorithm. Then another group with Fabian Eidner and Desmond Leung, they approached the topic from a really kind of a maybe more socially driven point of view. So it's that project was really about extending existing building stock with a lightweight timber structure, and really really analyzing what would be the details to be solved for this kind of typology. And what they're proposing was basically to analyze the grid structure, the space frame of the timber structure, and kind of synthesize a grammar of tectonic situations. And then, of course, you drastically simplify this kind of complex assembly of elements into actually a very simple set of logical routines that then you just need to feed into the model, and then you can just generate your designs. Yeah, and then the last group that I wanted to show today was group 3 with Shai Gregorian, Divak Tamilmani, and Dominik Reisach, which was also very comprehensive, and it was really great to see also the participants to really start collaborating so intensely within the group, where basically our Discord channel was exploding with new ideas and exchange of models, and we almost had a hard time to keep track of what is going on, and to give feedback and also give assistance with the scripting and with the modeling. And what group 3 was basically also proposing is to understand the grammar of these assemblies from a kind of bottom-up approach, and they came up with almost like a full catalog of different situations that are meaningful in the one way or the other. And this is just a snapshot of a couple of those interesting kind of explorations. And what is kind of amazing to me is that they really as a team managed to then synthesize all of these different explorations into one kind of design proposal, where of course the result is kind of a collage of different kind of grammars, or kind of a different language, right? But that was really the idea of what they wanted to show, is that you can design like a rather meaningful structure based out of very different kind of logics of how you assemble actually your sticks. And yeah, with that, I think we're through most of the groups. Also the others, I didn't know how much time we have to present actually. There was even more fascinating projects that are now just skipped due to the time. Another thing that I wanted to mention is that what we are trying to do most of the time, given that it's an online workshop, is to invite really lots of people to the final presentations, so that we can really also start a conversation around the explorations that were done in the workshop. And this is really this really proved successful in some way or the other, because I guess it's really easy in this kind of fully digital kind of environment to both invite someone to a presentation, right, but also to join. And it proved so much. It was so much fun to have all these people join the presentations and give their feedback to the participants. And I think not only it serves as a networking event, but of course also as a transfer strategy and kind of like a feedback between industry, academia, and also practice. In this case, I think we were also very happy to have two representatives of arguably the two biggest timber construction, robotic timber construction startups join the presentations and really provide feedback and exchange ideas from a really practical point of view, from the industry with let's say what we did in the workshop as a of course as a kind of like free exploration of maybe structures that still need a bit of engineering and a bit more of thought to really be built. But I think that was a very interesting conversation. And with that, I guess I also just want to say thanks again for everyone who's joining us on the last day. And yeah, I guess now I would give over to Chahua and Professor Yuan that will show the demonstrator on site.
Yeah, okay. So first, thanks, Jakob, for introducing the online workshop. And I think this year we really have a group of very talented participants, and we also have very exciting outcomes within this very short time span. So for me, as Jakob has mentioned, this workshop is an extension of the collaboration last year between ICD and Tongji University, and I'm really my pleasure to be part of this collaboration. And could you see my screen now?
Yes, it's
Yes.
better. You can present it. It's not in presentation.
Okay.
Yeah.
Okay. Okay. So for me, the difference this year is at last year I'm like exchanging in Stuttgart in ICD. So all the workshop is went online, and this year I could have this opportunity to actually fabricate this pavilion in the campus of Tongji University as a demonstrator of the system we are proposing. And today I prepare a very brief introduction. It's actually the video made by our participants of our on-site workshops. So I'll start with. So the design is based on the same logic or same context Jakob just introduced. So we first designed a catalog of different tectonic systems, which is correspond to the different different type of intersecting joint or axis of the structure system. And we design this set of joint system, or we can call it a library. We can use this kind of joint library to by combining the different types of joint system, we can design different type of design or structure system. And then the robot will be moved on site, and it can locate itself by recognizing the embedded markers on the ground. And then it will follow this procedure from gripping and gluing the stake, and then place the stakes to the designed location, and one by one to assemble this structure. Okay, so the structure is subdivided into several clusters according to the different robotic robot locations on site. So the and all the stakes could be like sorted according to the assemble sequence. And here's some video from the on-site fabrication. And during the fabrication process, the robot is mainly responsible for this packing, gluing, and placing. And all the stakes is fixed by with like manual assistance. And each time the robot moves from one position to another, it will try to locate itself with the markers embedded on the steel plates, and then the cluster of the corresponding location could be fabricated. And here's some images from the fabrication process. And I'm really glad that we can finally make this structure in this very short time span. And this pavilion, it could serve as some seats or a cover of this in this place. And although we have encountered a lot of problem robotic wise or the design wise, but I think we are really very pleased to see this structure finally present here in the campus, and also be able to show it here in this event. And here's some image we'll take before the exhibition. Okay, so I also would like to take this opportunity to thank our all our participants on site, and they're very hard working during the last week that makes this work possible. And thanks our teams and all the participants on site. And yeah, I think that's it.
Okay, would you please quit the sharing your screen? I want to briefly add some comments. So thanks a lot to Jacob, and thanks a lot to Archimangus. I think it's a great collaboration between Tongji and ICD over the past, I think it's 6 years, over the past 6 years. This year, I think the on-site mobile robotic construction platform is an extension of last year. Actually, over the pandemic, we have a great collaboration last year to make a mock-up, especially which is an umbrella shape supported by one column. But the beam system is actually optimized by the structural performance and fabricated by the robotics. And this year is more, I think, is more interestingly, Jacob teach a really fantastic workshop. I participate into the final review, and the jury from all of the world, 7, 8 juries make a very interesting, fantastic comments. I think, briefly speaking, it's a very experimental research on the on-site Glulam system, because normally this kind of laminate wood is fabricated in the factory. But actually, in the real scenarios, in different projects, we find a lot of potential possibility. If you can laminate wood on-site, we give a great opportunity to provide different scenarios, actually, which will pose into different paradigm shift, especially based on the structure performance simulation. So over the past years, I think Achim and me, we have set up an international collaboration, especially from Tongji side, we actually open all the resources we have. And this platform is developed last year. And this is the second year we optimize this platform, and looking forward to critically set up on-site fabrication by this Spatial platform. Actually, this is the 8th generation of the on-site mobile platform in Tongji. And this year, collaborating with Fab Union, we developed a 9th generation, and the 10th generation is on the way. So it's a very fast generative developing process by this kind of thinking. And the most critical question goes from the jury actually to this project is as to the paradigm shift. Le Corbusier put forward the Dominic system, which is a column and beam system over the past 100 years. But right now, it's probably have a new paradigm, a new manifesto on the system, which is totally bottom up and totally emergent, which could be generated by the GAM architecture intelligence, and could generate by the structural performance simulation. And the agent is very important. The agent could be a small component, even though in this kind of material-based, material intelligence, a special timber. And based on the special logics, which is not only the shape grammar, but also could be overcome to the density of the material, and the structural performance could follow by the generative process from a lot of different, like amoeba, different kind of performance-based structure and design softwares. And this kind of software generates the form, which is not the straight linear form, which is totally unlinear, and also the density is changed and based on the logic of the flow of the forces. So this on-site platform gave a very interesting potential possibility to set up the material intelligence, which is relevant a lot to the e-material intelligence generated by the AI in the future, and also have a lot of collaboration, connection to the agent-based, multi-agent-based formation. So it's just, we want to open a window to the future that is probably not just based on the prefabrication from the factory, but the prefabrication on-site. That is really interesting to engage all the designers, and also the fabricators can collaborate it more closely, and to generate and fabricate and construct different buildings. So it's just a very beginning of this research, and looking forward, critically not the material of timber, but also could be 3D printing, and also other technology could be moving to on-site. And this kind of on-site fabrication will be more interesting in the future. But right now, the problem we over there the past 10 years, 10 days, I think we have some problem. It's a lot of work is still machine and human collaborative process, because this kind of QR code location is not very efficient and accurate. We need use different technology to position each component on the global system, and the local components really have a strong corresponding to the self-gravity and the global gravity, normally which relate a lot to the joints. The joints matters. The joints right now, the news still need, and the glue normally needs some time to make it the stiffness set up, so established. So it's still a long way to make a more efficient process by this platform. Although we're facing with a lot of difficulties, but I think And Jacob, in Jacob's teaching workshop, we see a lot of potential possibility, especially the generative process to design the joints. I remember an Indian student who is really talented. I think make research on the Chinese and Japanese furniture joints, and which gives a very interesting finity element based design methodology to design the interlock joints, and which is strongly corresponding to this on-site fabrication. It's not a process of replacing the human labors. It's kind of new creative process from the machine, which can even more smart than human being and could be more efficiently, more accurately than human being. So that is machine give us. I think it's a great opportunity, a great future. We are trying to keep working on this in the next few years. I think I really appreciate Archimanga's team from ICD, and Jacob really engaged a lot to the whole process. Quite efficient, quite short time in this workshop, but this really productive, give us great imagination and ability based on this kind of material intelligence process. So thanks a lot to Jacob, and thanks a lot to Chaihua to teaching the workshop. So Achim and me will support this research in the future, and also cheers for the collaboration. It's a totally international collaboration. The students in this group from all over the world. It's a great exchange ideas and also exchange knowledge. And the critics really put forward interesting questions. We have a lot of questions need to be solved, but that is just a great opportunity for us to moving forward. So thanks a lot. That's my short comments. Thank you.
Thanks, Philip. That was, I think, what it's over the next few weeks we'll get a chance to look at some of the other workshops, and of course, during the event itself, during Inclusive Futures, we were all very intensely kind of locked into our own workshops. So it's great to find out what else was going on. Yeah, I mean, I think I don't, Philip, I think the disasters are always quite good to know. I mean, I think if you're an engineer, you want to see a structure collapse so you can see where the problems are. So maybe the challenges in trying to locate your things in 3D and so on are actually, this is a productive thing. Anyway, so we have a chance for some discussion now. There are some questions coming in from the workshop, from the side, from the chat. And I'd like to invite anyone else, if they want to contribute a question, to do so. So maybe we can open up. Virginia, I would like to, if possible, it'd be great to see you. You've been, Virginia, I should say, did an incredible amount of work behind the scenes on everything. So it'd be great if you could come and join the conversation.
Yeah, and also I think you could kind of see in the beginning video my workshop. Yiga Liu was coordinating with me on that, and she built a large installation also at the exhibition space there in Tongji. So I know how much time and energy goes into preparing for these large construction workshop projects, but then also coordinating with students to bring them in. I found that it was really great to learn not only from our own process of making and teach that to the students, but the students also bring these ideas, new ideas to the table, right? There's like such a new collaboration between instructors and students. And like you were mentioning, having this student from India taking things to a step further and things like this. So I think that through all these inclusive futures events and digital futures events, we're always learning together, which is super important. I didn't really have any questions prepared, but I think that the work is really great. I think that the things that were built were really, really quite beautiful.
Yeah, maybe I could just ask a question for those of you who are involved in these hybrid workshops. What were the challenges? I think one of the things that we've discovered during the pandemic, is there are some opportunities and some challenges. I know that Sumin Ham has been using AR as a way of fabricating things remotely. But what were the real challenges about operating in a hybrid workshop?
I think probably still because all the workshop have a very large amount of work, and we still need time to organize in the exhibition, and the videos is coming in the next weeks. But today, I think it's a first review. Maybe probably it's just a few teams, and next weekend I'm looking forward to invite more from Asian Pacific, especially, and to present their work, because Yi Ge and Wang Xiang is both of them got ill, got sick because of the hard work over the past 10 days. So probably they need some time to take a special rest. And the next week, the two teams can present very well. But I think because Nick Ball is here, Nick actually teach two workshops in Asian Pacific, especially in Tongji. Both of the project already constructed. Would you please, Nick, to present part of the final result? Maybe the video could be coming next week, if you like. Is Nick here?
Nick's here. I'm not quite sure if he's ready yet. Why don't we just quickly play that video again, just to remind us of the of Virginia's structure and Nick's structure, and also the bridge.
Yes. Okay.
Yeah, and I don't know, Philip, if you can speak a little bit more about the bridge. I know Neil tried to mention some of its importance, but it's really well highlighted in this video. So.
Actually, the bridge I'm teaching with Philip Block, because Philip Block and me is collaborating, working on a huge project in Shanghai, which is over more than 100 meters span. This is like a mock-up of that huge project. And we make a lot of discussion. And the bridge actually is a composite structure system, which is really complicated and really challenge. And we argue, the two teams make a lot of discussions and argument. And probably, I think, will be a lot of papers coming followed by this bridge construction, because no matter the generative process of the form, but also the structure for performance is really a strong challenge to both teams. And Wang Xiang, Assistant Professor Wang Xiang, is right now teaching Tongji University, and he actually engaged a lot into the construction process. And we thanks a lot to the material company. They gave us support on the high performance concrete from Beilida in Nanjing, and actually gave us a lot of support to the project. At the same time, we thanks to Fab Union, Yizao Keji, they actually help us 3D printed the handrails and also stairs. That is a new technology we developed over the past 2 years, and that is two material. It's not just the concrete. We also add some basin into this very special concrete and high quality. I think it's totally different to the contour printing. We already overpassed the 100% concrete. It's like 70% concrete and 30% it's some other plastic material. It's we heat them and put them together, and that is a material science intelligence research. And right now, still we need at least 1 week to take away all this scaffoldings, because the concrete is not. We need at least 2 weeks to take away the scaffolding. So you can right now still see a lot of steel pipes there. And at the end of this week and the beginning of October, we will take away all these scaffolding support pipes. And then I'm looking forward, we will invite over 20 people to standing on this to challenge this composite structure, performance-based structure. You can see the support is actually from the minimal surface, which is generated by the structure performance based formation tools, and we actually piled the concrete on it is around 6 centimeters. That is a real structure to support the whole weight of the bridge. And the handrails and the steps also have structural performance from the compression perspective. But if you participate the bridge project over the past 3 years, you will see this year the bridge is more flat. So because the compression only formation will generate form like arch. But this year we try to challenge, if not arch, if we want to fabricate a flat bridge, there will be more challenge. It's a composite structure. So part of this is actually supported by the knitting support, which is like a mold system for the high performance concurrence. And then we have this compression from the handrails. There's also composite concrete. We also have produce some compression only support. So it's like two kinds of structure system which composite working together. So Philip Block actually produced another small mock-up you can see on the screen, which is smaller one, and that is totally collaborating with them. We use correlation mode, which is knitting in Zurich. They sent all this knitting from Zurich in 3 days all the way to Shanghai, and then we piled the concrete on it, high performance concrete on it. It's really, and the small bridge only 3 centimeters, really thin high performance concrete, and then we'll take away the timber, and this super ultra thin system will produce the high performance, which will save the investment of the mold system. And actually cannot find any scaffolding, which will save a lot of energy. Even though in this project, you can see the scaffolding is only some pipes, which can just help us to generate the form, to accurately produce the form of the arch. So it's a high performance design approach, which is based on material intelligence research. I think right now we implement here. Also, we have GAN, machine learning in part of the structure, the arch of the bridge, but it's not totally generate the whole form. It's the material intelligence embedded in the structural performance-based formation, and also we correspond all this kind of process to the machine intelligence. Right now here in this project, we have the knitting machine, the high performance knitting machine, and we have the 3D concrete machine, actually, which is totally smart construction and robotic fabrication and machine intelligence. And actually which collaborating with each other and make this composite bridge possible. So I think this is the 5th bridge we designed over the past 5 years, and we have a lot, I think, progress. We make a huge progress, not only by the fabrication part, but also the design skills, and also to understand how the forces flow and how to present the forces flow. I think which we're learning a lot actually from Philip Block's team, and also Philip Block's, he also have a very high comments in the final review, because it's impossible for him to construct such a big bridge in such a short time. So I think all the teams have a great collaboration online, and thanks a lot to Philip Block. I hope next week, if possible, I would like to invite Wang Xiang and the PhD student, 2 PhD students from NCCR, ETH, and they can present all the animation video of the whole process of the project, because Wang Xiang got sick and right now in the hospital. It's a great pity. I think it's better to have him here to introduce all the details how to fabricate this bridge in such a short time. And we're looking forward next week, we can take away the scaffolding to show the beauty of this structure. I think it's a fantastic form. And all the tectonic structure is digitalized. and which present the future new technology, robotic fabrication technology in the future in architecture industry. So that is the meaningful research process by the two international teams, I think, which are posing to not only solving the problem, but also we put forward a new possibility for the paradigm shift of the material intelligence and the process of to generate the form, and also the process to fabricate the form. Thanks a lot. I briefly introduce this project. Thank you.
Yeah, and while we're still on this image, I'd like to just mention that in the left there at the very bottom, you can also see the pavilion that Yiga Liu and I collaborated on, which is a deployable knitted structure. So this one has wheels on the bottom, and you can see that the form can unroll and roll back together to collapse and expand within the space. And we worked on students for only 3 days to help fabricate this at this full scale. All the knitting had been done in advance, but the students for the first few days of the workshop learned how the knitting process would work to create their own deployable pavilions, and they made small mock-ups, which you can also see some of those within the gallery space, and hopefully we'll be able to share more of those in the online exhibition and in our videos and other things as well. But so it's really nice to see knitting becoming really important to the fabrication process with both this bridge and the deployable structure out here at Tongji University.
Yeah, Virginia, I think I strongly suggest you should present the details. It's really beautiful, the knitting details on this structure, firstly. And secondly, I think the deployable process of the whole structure, which could be folding into different pieces, and super fast, because you have the wheels as a base support for the whole structure. Actually, it's not just one form, which could be transformed by different degree of rotation. That's the kind of beauty of this installation. So
exactly. So it can become very many different shapes and forms.
It's fantastic.
Yes, well, I think that Yiga will be better to present it with us, because she worked very hard on it with me. So I just wanted to have one note while we were looking at this beautiful image, though, because it's there and it's great.
Yeah.
Thank you for that. That was I mean, hopefully we'll get to see more about the bridge and see it when it the supports come down, to see it in operation.
Yeah. All the 3D printing is finished in 5 days. It's super fast right now, and the scenarios of it is not just a pavilion, which goes to the architect's skill. And this is a pavilion from Nick Ball. Nick is here, actually. I think Nick would like to present this fantastic pavilion. And we'll have an opening on August the 2nd, offline, on this site. And we invited different guests coming here for the opening. Because the support, the scaffolding support is not taken away. We are looking forward, it could be like a pure bridge image in August the 2nd. Yes, Nick Bao, please.
So maybe I could just say a few words of introduction to Nick Bao. Just to say, I mean, first of all, could you wish Wang Shang our best wishes? I mean, it's I mean, incredible amount of work went into this thing. Wang Shang, to say, is kind of interesting in many ways. A product of the kind of collaborations that we, in a way, he studied at Darmstadt as doing his PhD in Darmstadt in Germany, and then came back and was a postdoc with Philip before now becoming an assistant professor at Tongji. And in many ways, Nick Bao has been doing a kind of similar trajectory in the sense that he went to Australia and studied at both RMIT and at Melbourne University, studied under some of the collaborators that we've had in Digital Futures. That is to say, Roland Snooks, Mark Barry, and so on, and is now and Mike Shee, of course, and has now completed his PhD and is a lecturer at RMIT. When I say lecturer, I should point out, and this is always a point of contention, lecturer in the English world, that is to say Australia and the UK, actually means assistant professor. So in other words, even though in the States lecturer is quite a low level, it's actually a very high level. And it's great that Nick has now been appointed as a lecturer at RMIT, which of course is famous in Australia as one of the most progressive schools of architecture, certainly in Australia and in the world. So Nick, maybe you could say a few words about your astonishing collaboration that we saw in that video. Nick.
Yeah, sure. Yeah, thank you for introduction, Neil. Yeah, I didn't prepare too much for tonight, but I just have a quick introduction of our workshop. So it's our third workshop in Digital Future from since 2019. Luckily we built up a pavilion in 2019, X-Form 1.0. It's also very beginning of my PhD study, part of my PhD study research. Then last year we purely online teaching the Bioform workshop, and also very lucky we collaborate with the China Construction Science and Technology Group, also with my supervisor Professor Mike Shee and Xin Yan, together teach the workshop Intelligent Form. Also this workshop is a hybrid workshop, including the online and physical workshops, and 2 workshops run simultaneously. So the international students, most of international students will study online, and all the Chinese students will involve in the on-site fabrication, also learn the online stuff. So the new approach to the generative architecture design has been introduced into the workshop. The student will be trained to develop their skills in architecture design through the application of the typology optimization, BSO software, Amoeba, and the concept of the typology optimization and the inspiration of the nature form finding idea will be run through has been run through the architecture application. So students has been required to complete a series of architecture or architecture components design and optimization individually, and also some of them are designed in pair, online and in person. So here is our instructors, including myself, Professor Mike Shee, Xin Yan, and our partnership from China Construction Technology and Science, Dr. Cho Wei, and our best instructor on site, Jianan Peng. So here is our teaching assistants from RMIT, and we also have 2 teaching assistants on site in campus, assist our students and the instructors build something in Tongji. So we got a lot of students from China and from the Indian and the Iran. They perform quite well, and we have more than 10 to 12 teaching outcome and works. So I will present it next Saturday night, and also all the students involved in the fabrication and also assembling the 3 meters high structures. So this one is made by 3D printing molds, and also spray the UHPC concrete. So this close-up view of the pavilion. So this is the quick video is sent to me today for the whole structures. So I will present the pavilion and the workshop outcome next week. We'll have more details. Thank you.
Thanks, Nick. Nick, I should say, is also on the team that's been helping to help it on a week-by-week basis, helping to make Digital Futures what it is. And what is I find astonishing is the way he's always at our meetings, and it's gone midnight when in Australia by the time those meetings happen. So, thank you so much for that, Nick. That's great to see. And it's great to see, I think also, I should say, Janan Peng is one of my students on the DDES at FIU, so it's great to see how this is all feeding in from the doctoral students around the world. I think now we got a few minutes now. We can maybe sort of have a little brief discussion about these operations this week. I mean, we'll see about what's been presented this week. We'll see next week. In fact, over the next few weeks, other workshops. But maybe it's a chance to kind of to have a discussion together between ourselves. So I'd like to invite those in our team here to switch their videos on and be part of a discussion.
Well, I think I just want to thank everyone again for all their hard work. I think, Emmanuel, you presented your work at the very beginning, and you taught an online workshop completely. So I think it's quite interesting seeing these pavilions as well as the fully digital type work that you were doing mixed together. I wonder, have you ever thought of fabricating some of your pieces once they've turned into these kind of 3D voxel things? Would you 3D print them, or how would you think you would fabricate those? And is that the next step?
Right, thanks. Well, actually, for the example that I showed you, the Venice Biennale, currently I'm in the process in my lab. We are going to 3D print it, and well, have to wait for more confirmation. If everything goes well, then we'll ship it over to Venice in November. So we are in fact 3D printing I think you probably saw the 3D GAN with the entire housing structure with all the parts in the video. So yes, fabricating it for sure.
Actually, I think this year is important because the China Construction Group gave a lot of support to the RMIT group. Actually, they have two teams, and hopefully next week can introduce more interesting details of the, including the process is more meaningful. That means not just the workshop scale, because it's too compact, only like 9 days or less than 2 weeks. It's not enough. It's a great challenge. But actually, not only China Construction Group, but including Fab Union, which is Yizao Keji, already make a huge progress, which is out of your imagination over the past 2 years. So I would like strongly suggest invite New Leach to coming back to see what's happening in these two years, because the robotic is engaged really into the construction. And we have a lot of works on the way, and which is parallel going on. Not only 1 or 2 teams, actually the whole construction industry is influenced by Digital Futures and by the people we strongly gave promotion over the past 10 years. I think we have collaboration with Shanghai Construction Group and also with China Construction Group. And it's not only, that's only 2 parts of the country. But I think the more meaningful thing is not just pavilion scale, is actually a strong agent which connecting the emergent or the generative design methodology to the fabrication scenarios. It's a strong connection between these 2 methodology. I think at the very beginning, you remember, we just test very small pieces of 3D printing by the spatial tools collaborating between Tsinghua and Yulei and Tongji teams. I think it's around 8 years ago is spatial printing. And right now, actually, we can print huge scales, collaborating with different teams if they have the 3D printing machine, and we can work in a really huge project. And my team actually is working on several very meaningful projects, which will come in the end of this year and the beginning of next year. I think which we're running on the way, which is strongly based on, I think this kind of workshop culture gave a very strong potential possibility. It's not very much engaged into details of technology, but it's kind of culture we set up. It's a direction how to moving forward. I think it's meaningful collaboration between, for example, from CAUP, I think, and Archimangus. We can see a lot of experimental pavilions, which is strongly based on the performance-based methodology, which putting forward by Archimangus at the end of 2008, 2007 in AA when he teaching there. I think after that is around like 15 years, and the industry is following up in these 15 years. And the most aggressive is from China Construction Group, this kind of huge company. I think they are the largest construction group over the world. So in the world, so I think they just set up a lot of very interesting robotic factory around Shenzhen, near the suburban area of Shenzhen, and also around Shanghai, Yangtze Delta, and also Beijing. They have very interesting the robotic factory scenarios right now. And robotics is not just like a machine, which is individually working on a pavilion, which engage into the process. I think which newly just mentioned, the process is important. It's not, it's an information process and also a fabrication process. The data actually is flowing from the generative, your imagination as a process, and also fabrication and material intelligence kind of process. So we should collaborating more intensively by this group, I think, which is meaningful to the direction how to move forward. It's like a common ground from a group of people. It's not from individual researchers or the educators. Actually, I think we will play great influence to not only the industry, but also the pedagogy, which is should be challenged and should be critical thinking how we organize the studio and how to organize the design courses. I think RMIT doing a really good job. It's kind of culture evidence-based and based on the pavilion. And Roland Snook, Mike Shea play very important roles there. And right now, Nick Bao is growing up. And I really appreciate to see the studio exhibition in RMIT is really fantastic. And also they invite me to be a visiting scholar next semester and teaching maybe part of their students in mainland China because it's pandemic make it impossible for traveling. But I think I would like to say it's a great collaboration. We can teach each other and learning from each other. And the most meaningful is kind of exchange knowledge. We're moving forward together. So that's also the inclusive futures which we set up this year. As not only from the cultural perspective, most important is kind of a technology culture, and also that is what they were doing on the way. So great thanks to including all the team organizers here. You invest so much time and so many energies in the whole process, including Igor and Wang Xiang. Both of them got sick, and they're working too hard over the past 2 weeks. But with thanks to both of them, and hope they can be healthy and recover very soon. And I think today is just a beginning to present the workshops. We have 109 teams, and in the exhibition, actually, more than 50 teams gave their panel information. We all present them in Tongji, and still we're calling for more workshops information. And please send to Digital Futures Group, and we would like to present it different ways, online and offline. I think which will be extremely important to present what we're doing to the public. And no matter the depths, and because it's super compact workshops, but I think the culture we set up is more important. And thanks a lot to the instructors and also the organizers here. And thanks a lot to Jacob, and say hi to Achim.
So maybe I could just add a few words, Philip. Thank you. I mean, I always, whenever I kind of talk about these things, I always look back on a comment that was made by Brett Steele, and I forget, it was 2008 or something like that, when they had the 10th anniversary of the AADRL, which was set up, and he said, you know, when you look so far forward in the future, you don't often look back and look at the history of the thing. But I think it's important to think about the history of the thing and how things emerged. And I think about that particular time at the AA when actually Achim Menges was a student still there, and so was Neri Oxman, and how that has led to this incredible process of passing on information. So something remarkable has happened in the last few years. I like to think that actually one of the most important things that we've done, and let's see how it develops in the future, is to establish some kind of platform for doctoral research. I think this is in many ways, who knows what that's going to bring either, but in many ways, in sense of bringing people together, the real problem about doctoral research is you're working individually in your own institutions, and often those institutions don't have the resources to maybe to cover all the teaching. And the idea behind the digital consortium is to maybe bring people together so you can share resources, so you can get people like Achim Menges presenting and have a range of the best in the world as your instructors. And I think that's an incredible step forward as well. So who knows what that will lead to? But I just want to mention that there also, in addition to the presentations that will be happening in the next few weeks, we have a repository of videos of all the events this summer, and that includes the lectures. And some of them have got a lot of hits. So let's hope that all this will kind of lead to something positive in the future. It seems to be that the key is connection and developing a kind of network of informational processes that will no doubt lead to who knows where it will lead. Who knows where it will lead. But I just want to repeat that kind of comment that Philip made of thanking those who have been behind all this, because it couldn't happen without the instructors, willingly giving their time, which is an incredible gesture of generosity and sharing of knowledge to the people less advantaged, to those in countries where, frankly, people can't afford to study abroad. And it's amazing that how knowledge is being shared in that way. But I also wanted to kind of mention the team that's behind all this. And there is a team that's been working flat out. Some of them not even visible, and without that support, and all voluntary as well, then none of this would happen. So I think one thing I really want to hope is that we're beginning to, not only in terms of the techniques that we're talking about in terms of knowledge itself, which I think hopefully we're pushing forward the boundaries and opening up new realms, but also in the nature of education itself. It seems to me that maybe this is something that we can contribute that will help to revolutionize education worldwide, that we somehow have established a platform now where everyone could communicate on a regular basis. So I think over the next few weeks, we'll be finding out more about these individual workshops. I know how much work went into them because I was behind them. I was behind one of them, along with other colleagues, and I know how much work went into the lecture course itself. But and who knows what it'll lead to? I think it'd be interesting in 10 years' time to do what Brett Steele did 10 years after the start of the AADRL, to look back and realize what has happened out of that. But already today, I think we've had presentations from Emmanuel Coe, who was a student on the AADRL. He's been able to share knowledge. So we will be establishing something for the future that will have all sorts of astonishing benefits in the future. Maybe I could just simply ask those presenting today to round up with a few comments. I would like to start with Emmanuel Coe, since he was part of what I was discussing, part of this kind of knowledge transfer, and now, of course, teaching in Singapore. Emmanuel, would you like to offer a few closing remarks?
Right. Thanks. I really appreciate this effort. I'm not behind any of this, but I could imagine how complicated this whole affair is. So I really appreciate all that hard work. And it's amazing how, all the way back when I was teaching in AA Shanghai for Tom, and you were doing this thing with Tongji, and who knows, actually it became this digital future monster in the end after 10 years or so. It's just amazing. And Yeah, I think it's also make it easier for other people to be somehow in conversation as well. I mean, in the past, it's really difficult to. I mean, I see you say talking to some, fresh graduates, like being interviewed by them. I can't remember his name, for instance. That is almost impossible in the past. But now suddenly you kind of flatten this hierarchy, and the idea of the PhD program being part of this makes a lot of sense, because often it's not just lonely. I mean, from own experience, it's actually a very lonely process. Yeah, especially in a very quiet, French-speaking Swiss city in Lausanne. And it helps a lot, especially if you could find like-minded people. Yeah. So yeah, thanks.
I don't know whether Hans Jakob wants to say anything. Hans Jakob is in Stuttgart.
Sure, I can say some words. I guess last year we were pretty, maybe a bit struggling with preparing for a fully digital workshop, right? And we were all very nervous. In the end, it worked great, right? But I think one thing to still take away from the pandemic is in the end it brought people closer to each other, right? And I think you guys you played a huge role in that, at least in our community. And I think this was said like 1,000 times already. I heard it a lot, but I think this is really what everyone just thinks, right? Because the last year would have been very lonely without that, and I think it's also just a great opportunity. You mentioned the Iranian students, right? But it's not even only the Iranians. Like there's even just professionals working in an office, right? It's way easier to just join workshops during work time if you don't need to travel around the world, and if there is a kind of a setup for something like that, right? And it's also, I think it's also just amazing how you motivate all of our colleagues to also share the knowledge. And I mean, we are very, very glad to be invited and to come and to provide what we what we have. But I think this is really also needs a lot of kind of convincing in some cases, and I think this is really, it can't be stated too much. I mean, just a couple of years ago, this was like an elite event, right? With only very selective groups being able to join, and I think this is really the right way to go, and just great thanks to you.
Thanks, Jakob. I mean, I mentioned Iran only because the country has a number of difficulties, and certainly financial difficulties, and not many Iranian students can afford to go anywhere these days. And yet we've seen so much talent coming out of Iran. But I think it's the same could be said, of course, with students from places like Bangladesh and elsewhere. We have some students from Brazil, where actually they even have their own computation. The computation facilities in Brazil are really not so good. But it's great to be able to be helping in that way and spreading knowledge in some ways. And to my mind, it's very architectural in the sense that there's always been this tradition of kind of being on each other's reviews. That's been part of the logic of architecture for years to come. And if you're passionate about what you believe in, then you don't mind sharing it. And I think this is somehow just simply articulating something that's already there in architecture. I don't know whether Chai would like to say a few things. I don't know whether. Chai, would you like to say a few things that you also present today?
Yeah. Yes, thanks, Neil. And I think this is already like the 6 or 7 years that I have been involved in this digital future workshops. But before last year, we are mainly works on mostly the on-site fabrication on-site workshops. And from last year, I have this opportunity to collaborate with Jakob on this online workshop, and we move on to this year to further explore these new ways to this hybrid workshops, separate the online parts, the offline parts. Yeah, I think the pandemic really give us the opportunity to explore the different ways that we can further promote this education things of the fabrication things. But through this 2 years of collaboration of this workshop, we can also notice that there is some, we can say, a little pity that we really have very talented participants from all over the world, but we can say we can explore the same topic in the same Zoom room, and the pity is that we it's really hard that what we did is the physical exploration of this robotic things, and in the future I think it's maybe a very great opportunity for us to further explore how can we merge these two parts into a very integrated workshop. So how the online participant could really also be part of this further physical experiments, how the on-site prefabrication of the robotic fabrication setup could be interact with the participant online. Yeah, I really appreciate this these opportunities to be part of those workshops, and hope in the future we can I can still have the opportunity to further involve. Thanks.
Virginia and Chao, would you like to say something, or finally to wrap up?
Yeah, I mean, I just want to say thank you. And I mean, obviously, as organizer of the event and also teaching a workshop, there's been so much to learn, not only from learning from the other instructors, but also from the students. And I think my workshop was hybrid. So we had a few students that were fully online and several students that were physically in Shanghai working on the pavilion. So as well, balancing this online and physical is difficult, but at the same time is very rewarding, right? Because we are able to collaborate with people that we maybe never would get to collaborate with before. And that's really where a lot of these inclusive futures can be seen as just people coming together from places where we might never have met before, and being able to think about these ideas that we maybe don't get to see every day, and have more empathy for the different perspectives of the world. So I think that has been really rewarding, along with, of course, all of the important technological things that we learned, skills, and all of that. So thank you. Chao.
Yes, I think to myself, I think this year is kind of a unique experience. Well, not only because I'm starting to teach an online workshop, but also I had the chance to kind of go back to the campus to coordinate different physical workshops, and also for the exhibition. Well, as a kind of witness to those physical workshops, I can kind of feel the energies on site back to the workshop culture. I think that's really an important things to digital futures, and also to kind of the learning process. But for this year, we have been working with a kind of hybrid mode to kind of working with the difficulties of COVID, and to start bring some kind of physical cultures back to the workshop. Maybe for in the future years, we can explore more different ways, kind of but if COVID is still there for could be there for several years, we need to work with those kind of difficulties, but at the same time we can I believe we can work out some other ways to integrate both online and physical sites.
Okay, lastly, I think I would like to thanks to Bai Yixiong and also Yu Wei, Chris Yu, and also both of them spend a lot of time. Also Cora Li and Li Keke, and I think we have a very good teams help us to stream live the whole workshops and discussions through YouTube and Bilibili. I think out there behind the screen. So great thanks to all of them, and thank you for your participation. So I think we should wrap up today, Neil. And looking forward, next week we'll better invite more speakers to present their workshops. And 1 week is enough to prepare all the videos. I think hopefully more teams will come in next week.
Yes, we'll be over the next few weeks. We'll have many more presentations. Yeah, I just want to kind of say final thing. I thank everyone, but there were some challenges this year, but that's a good thing. We can build upon our successes and try and respond. Try and rectify any problems over the years. Nick, sorry, I forgot to invite you to say something to wrap up. Maybe you can just you could be the finishing comment if you'd like. To say something about your final comments, Nick?
Oh yeah, thank you. I think Digital Future is very good platform, very important to my life as well. Like Roland Snook started from Digital Future, but 10 years ago, then he moved to MIT, become faculty. I'm also start from Digital Future for 2 to 3 years. Now I'm also joining MIT faculty member. So it's very important platform to myself, and I hope I can come back Shanghai next year for next year's workshop. Thank you.
Okay, so let's wrap up here and look forward to next week. In the next few weeks, then there'll be a series of presentations from the other workshops, and then we'll go back into our normal mode. So thank you for the presenters today, and thank you for all the workshop instructors for all the effort they put in, and thank you for the team, the support team that has put so much into making this happen. So thank you, and see you next week.
Thank you all. Thank you.
Bye. Thank you.